Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for isomorphic strings problem. Let's look at the problem description. We are given two strings S and T and we have to determine whether they are isomorphic. So two strings are isomorphic if the characters in one string can be replaced to get another string. All the occurrences of a particular character must be replaced with another character, and also we have to preserve the order of those characters, and no two characters may map to the same character, but a character may map to itself. So let's take a look at the example 1. First string is egg, second is add. So if we replace E by A and G by D, we get the second string. So this is isomorphic. E is mapped to A and G is mapped to D. All the occurrence of E is replaced by A. All the occurrence of G is replaced by D. So we get this word. That's why the output is true. But in this case, F is mapped to B and O is mapped to A. The second occurrence of O, if we replace that by A, because that is already mapped to O, we will not get this word. So that's why the output is false. The constraints are the length of the string is ranging from 1 to 50,000 and both the input strings lengths are same and they only contain the valid ASCII characters. Let's look at the approach to solve this problem. We are given this input. First string is egg, second string is add, and if we replace E by A and G by D, we get the second string. So these two strings are isomorphic. In the problem description, one of the condition given was no two characters map to the same character. Okay. To ensure that, we need to have two hash maps. One is for storing the forward map and second one is storing the reverse map. Forward map contains an entry for each character in the first string. Reverse map contains an entry for each character in the second string. So in order to determine whether the two strings are isomorphic, we have to traverse all the characters in the input string. So for each character we traverse, check whether there is an entry in the forward map. If there is an entry, then its value should match the corresponding character in the second string. Same thing for each character in the second string, we have to check whether the value matches the corresponding character in the first string. If those two conditions are always true, then at the end we can declare the two strings are isomorphic. If there is no entry, then in each iteration we create an entry for the new character in the forward map and new entry in the reverse map for the character in the second string. That's what I have listed here. First we initialize the forward map and the reverse hash map, and the forward map has an entry for each character in the first string. So we have E and G, and the reverse map has an entry for each character in the second string, A and D. So A and D is a key, and then we traverse each character in the first string. For each character, first we check whether there is an entry for the current character in the forward map, and we check whether there is an entry for the reverse map for the corresponding character in the second string. If there is no entry, then we create one entry in the forward map and one in the reverse map. But for the case where there is an entry present in the forward map as well as in the reverse map, we have to check whether the value of that entry matches the corresponding character. For example, when we see this character, assuming there is an entry already, we check whether the value A matches the corresponding character in the second string. Basically the character present at the 0th index. So it matches with the value, so we are good. If it doesn't match, then we have to return false. Let's look at the flowchart. Input for this procedure is string first and second, and first we initialize the forward map and reverse map data structure and then the index to 0 and count to the length of the first string and the return value to true. Okay. Then we enter the for loop. We check whether we processed all the characters. If not, we go ahead and fetch the characters present at the index from the first string and second string and assign them to the variables fc and sc. Then we check whether there is an entry for the character fc in the forward map. If there is no entry, then we go ahead and check whether there is an entry in the reverse map for the character sc. If there is no, then we create one entry in the forward map for the character fc and one entry for the character sc in the reverse map. Okay. But if there is an entry in the forward map, what we have to do is we have to get that value and compare that value with the corresponding character in the second string located at idx. Okay. If they are matching, we are good. Otherwise, we have to declare the strings are not isomorphic. So we update the return value to false and then we break out of the loop. Same thing in the reverse map check also. If there is an entry for the character sc in the reverse map, then we check the value of that entry matches the corresponding character in the first string. So that's what we are checking, whether that value of that entry is equal to fc. If it is not matching, then we have to return false. Then finally we return the root val. Let's move on to coding. First I rename the input strings to first and second. Then I initialize the count variable with the length of the first string. Then I initialize the forward map and the reverse map, which is a map of byte to byte. Then I write the for loop which traverses the characters in the input string. Each iteration I read the character at index I from the first string and assign that to fc, and I read the character from the second string and assign that to sc. Then I check whether there is an entry for the character fc in the forward map. If there is an entry, and I check whether the value of that entry matches the corresponding character in the second string, which is sc. If it is not matching, then I return false. And next I check the reverse map, whether there is an entry for the character sc in the reverse map. If there is an entry, and then I check whether the value is matching the character in the first string, which is fc. If it doesn't match, then I return false. Otherwise, if there are no entries in both forward map and reverse map, then I create a new entry for the character fc and a new entry for the sc in the reverse map. Finally, I return true. Next, I am going to run the test cases. All the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So the first string is egg, second is add, the expected output is true. First we initialize the count variable with the length of the first string. So the count is initialized with 3, and next we initialize the forward map and reverse map data structure. So both are empty, and then we enter the for loop. In the iteration 0, first we initialize the 0th character in the first string to FC and the 0th character in the second string to SC. So E and A. Then we check whether there is an entry in the forward map for the character AFC. In this case it is not, it is empty. And then we check whether there is an entry for the SC in the reverse map, that is also not present. So we go ahead and create an entry in forward map as well as the reverse map. So when we leave the iteration 0, we have an entry in the forward map and the reverse map. In the iteration 1, we read the character at index 1 and assign that to FC and SC, and we check whether there is an entry in the forward map and the reverse map. It is not present. So we go ahead and add an entry for those two characters. So when we leave the iteration 1, we have an entry for G in the forward map and the entry for D in the reverse map. Next we enter iteration 2. We read the character at index 2, which is G, and we check whether there is an entry in the forward map for that character G. There is an entry. So in that case we check whether that value is equal to the corresponding character present in that index 2 in the second string. So it is matching. So the value of G is D, that is matching this D. Similarly we check the reverse map also. So we check whether there is an entry in the reverse map for the character D, and there is an entry and its value is matching with the corresponding letter in the first string. Both the conditions are false, so we go ahead and proceed to the next iteration, but we reach the end of the string. So at the end we return true. So that is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time and space complexity analysis for this input. Okay. The time complexity is order of n. In order to determine whether these two strings are isomorphic, we have to traverse all the characters in the input string. Okay, so this for loop traverses all the characters in the input string. For this input, this loop performs 3 iterations, and for n characters this will run n times. So the time complexity is order of n. Space complexity is order of n. So here we are allocating space for the forward map and the reverse map. The size of the forward map and the reverse map depends on the number of unique characters present in the input string. For example, even though the length of this string is 3, we actually need space for 2 entries in the forward map and 2 entries in the reverse map, because we have 2 unique characters. If all the characters are unique in the input string, then we ended up allocating n number of entries in the forward and the reverse map. So the space complexity is order of n. Thanks for watching this video. Have a great day.